Hi everybody, how you doing? Thank you for coming along to our talk on using AI to transform fleet operations. My name's Mubine Din and I work at Hitachi Consulting within the strategy and innovation team.
Hi, I'm Lamont. I work in our digital transformation practice in the UK.
Brilliant. So today we're here to talk to you about Hitachi's predictive maintenance platform for fleet operations. Just to give you a bit of an overview of how this session is going to be structured, it's going to be similar to everywhere you've been already. We're going to essentially tell you why we've done what we've done over the past 3 or 4 months. So giving you some information around the industry issues we're trying to tackle from a fleet management perspective. We're going to spend some time showing you how we've done what we've done by taking you through the architecture and taking you through some of those challenges and design decisions we've made, and then we're going to show you, because I think that's the most important part, right? You want to see what we've done, and we'll give you a demonstration of how we've applied this with one of our clients as well. The key thing I think all of you are probably wondering is, why do we have Lego? So let's address that elephant in the room. You've probably walked around the conference rooms and seen the Lego at the booth, and I think more people have been fascinated by the Lego than anything else. Essentially, it's a whole lot easier to bring one of those from the UK than bringing an actual vehicle. So we've got this to support one of our use cases around AR-guided inspections, and we'll give you a lot more information about that as we go through this session. If we could hold all questions until the end as well, we'll allocate some time for that. But if we don't get around to you because we run out of time, please swing by the booth, ask for Meredith. She'll be able to help you out there as well. Thank you. Perfect. I think we've talked about this, but essentially our aims are to show you what we've done, explain why we've done it, but also show you where we're going next. And just to give you all a bit of context and information about Hitachi, so you've all probably heard of us because we touch pretty much all industries from an industrials perspective to a technology perspective. We are a global technology leader, founded over 100 years ago, and a global industrial powerhouse with long-term stability and deep resources. Hitachi has deep experience in the industrials and manufacturing space, and especially within the kind of vehicles and fleet management space. So there's some interesting information up there. I won't talk about all of it, but over 70% of vehicles have at least one Hitachi component, and Hitachi manufactures components that amount to up to 45% of the component bill of materials you'll have in a vehicle. So we have deep experience in the manufacturing space there. But we also, as Hitachi, have a lot of experience in the ownership and operation of large fleet operations as well. So that's spanning from the automotive to the trucking to the heavy assets, so your earth-moving materials as well. And along those lines, Hitachi's also got deep experience around IoT, AI, and we're bringing together those with our use of Google as our platform for bringing our industrial experience and heritage to the industry to help our clients within the industry innovate and move forward. We also are a combination of 800 plus subsidiary companies, and that's how you've probably seen a lot of Hitachi touch in your world. So what are we here for today? So today, we're here to talk about fleet management and how predictive maintenance can support fleet management activities, fleet optimization activities specifically. Fleet management solutions need to evolve. They need to move from where they are. Currently, fleet management solutions are often reactive visualizations of the information that you have available to yourselves. Reactive in terms of maintenance, but also reactive in terms of any kind of optimization activities as well. Today, fleet organizations essentially have to compete with a number of disrupting factors, such as startups, other entrants into the market, rising fuel prices, and complex emission-based regulations that's forcing them to focus on efficiencies. And within that, maintenance costs for fleets account for 15 to 20% of your fleet's total costs. So a prime area for optimization and a prime area for AI and IoT-based solutions to help reduce that cost. Digital technologies are changing most industries in all areas, and this is somewhere where there's a great opportunity to provide efficiencies and cost savings. Just to give you all a bit of contextual background information, there are a number of fleet maintenance optimization challenges that need to be addressed. So fleet managers often lack the pertinent asset condition data. They may have data, but a lot of the data that gets collected across fleets is captured by individuals as opposed to necessarily being streamed back from the vehicles themselves in all instances. There's excessive operational maintenance costs. So a majority of organizations from a maintenance perspective do periodic or cyclical maintenance, where essentially you are maintaining the asset on a time-based process to essentially reduce the risk associated with that asset failing at any point in time. That's due to a lack of available asset condition data and a limited understanding of the relationships between the asset failure events and the data that you can get from those assets beforehand. Assets are becoming a whole lot more complex as well. So fleet operators are having to manage at larger scales with more complex assets, and that brings with it its own nightmares as well. And there's also the challenge around knowing when to maintain your assets and when to replace your assets. So for example, end of life for assets is calculated by organizations, usually on a time basis. We can bring additional data in to help those types of organizations retire those assets and replace those assets when they need to, not just because a certain time has elapsed. So this is the maturing process. The move to predictive maintenance doesn't happen overnight. We're on this trend moving from data reporting through to descriptive analytics and dashboarding to help people understand their assets. And through the use of data and bringing in data, you're able to move to the predictive world before we get to the prescriptive world where you're doing things because you feel they're going to fail, or you're doing things before you need to do it. Moving to predictive maintenance is expected to save 10 to 20% over preventative maintenance practices, and we'll break that down a little bit as we talk through this conversation. And why now? The big question is, has this not been possible previously? Why are we able to do this at this point? Technology convergence is a key reason we're able to essentially bring a number of different data sets together from both edge devices within vehicles, within assets, as well as streaming data from other data sources. So we're talking about the Met, we're talking about condition data and all those pieces, enabled by cloud computing and big data toolkits. So they really allow us to stream and store vast amount of data efficiently, economically, and securely, providing monitoring capabilities and the ability to make interventions before issues occur. AI and machine learning can be trained against these large data sets at comparatively low costs compared to in the past. And advanced visualizations through the use of augmented reality and also automated dashboarding and those elements can help surface the information to the right individuals at the right time so that they can make those interventions as needed. And the big question we have to ask is, well, why do you do these things? Why do you go through the pain of understanding and working through those data elements? And it's all about delivering value for the organizations. So fleet operations are essentially anticipated to reduce costs by moving to predictive maintenance, improve efficiency. So I'll give you a few examples. If we look at maintenance as it stands at the moment, we talked about it being done on a cyclical basis. If you maintain assets when they need to be maintained as opposed to for the sake of it, you reduce the downtime for those assets. So for example, you don't need to take vehicles out of service to go and do maintenance against those assets. You therefore make those assets available and you can improve your revenues against those at that point. You're reducing your operational costs. You're not having individuals having to go and service assets that do not need to be done. And you also are able to manage your CapEx and essentially focus and work on those assets that need the work when they need the work. So I've given you a bit of context and a bit of information around why fleet organizations need to consider predictive maintenance, need to understand their assets better. And that's understood, and that's a key driver across the industry. However, there are technological challenges associated with this in terms of streaming back fleet data. So a lot of the data that you pull off the vehicles, for example, are unstructured, or the data sources that are available come through as time series data with varying structures and schemas. IoT data itself isn't going to help you generate insight. Insight comes together from a combination of additional contextual data sources, so knowing the actual events that were occurring at that point in time, climate, temperature, terrain, where you were with that vehicle. And also, within the work we've done, we've identified that you need SME input. You need the knowledge and information from those SMEs that are working in that space to help you focus on the right use cases. You can bring back data from many sources, but unless it's actually serving a purpose and working for the use case to help the organization deliver value, it's not going to be worthwhile. Perfect. So I'll give you a bit of an overview here around what we have created and why we've created it. So essentially, Hitachi has used GCP technologies to deliver a predictive maintenance fleet operations solution which overcomes some of the challenges I talked about. We do two things predominantly, and we'll go into a lot of detail around this from a actual feature perspective and functionality perspective, but just as a high-level overview at this point, we've created data dashboards for maintenance planners that look at the data that we pull out of those vehicles compared to contextual data sources, and they look at the fault information that we've already created and the AI models we have created to predict fault events, and they surface the right recommendations to that maintenance planner at the right time so they know where and when they need to maintain assets. Comparing that against the alerts that are also coming back from the vehicle so it can be dynamically updated throughout their kind of planning process, but also looking at the normal maintenance schedules as well for those assets that are not quite ready for this. What we've also done is working with our client around the maintenance and inspection space as well, is we've helped them identify where they need to work on their assets, and we're using an AR-guided inspection application to help their largely mobile workforce understand the steps they need to take to complete that inspection against that vehicle. So our client has a large mobile workforce, but they also have a large number of contractors that they use as well. And the use of an AR-guided application has been super useful to helping those contractor workforce individuals understand what they need to do and where they need to do it. We'll give you a demonstration of that as well. So that is using the AR components of Android, but also using Google Glass as well. So, in terms of giving you an overview of what we've done and how we've done, I'll touch on the concept. So, our solution looks at the end-to-end using GCP, all the way from data ingestion from either the OBD terminal that we have in the vehicle or additional sensors that we instill in that vehicle. And Andy will take us through in a little while the Google GCP components we use from an architecture perspective and why we use those. We bring through the data in both stream and batch depending on the use case. It's all around what we need to show when we need to show it. And then using Google's capabilities from an AI perspective, using AutoML, ML, we essentially are doing the analysis against that data set to identify those fault events. And we're visualizing all of that information through assisted reality and data dashboards using Google Data Studio and also the mobile and glass applications I talked about. So just to give you an understanding of why we're doing what we're doing and how we got to where we are today. Within Europe, Hitachi own and operate a number of rail trains, and we provide those trains to organizations, but also they do the maintenance services against those vehicles as well. As Hitachi were creating those trains, they were looking at what data we would need to pull back from those vehicles and structuring the development of those and also the development of the data capture elements on those trains to bring back that information so we could do things like asset monitoring and asset optimization. That has evolved as we've moved on to the GCP suite, where we're looking now with our fleet clients, which we'll show the demo for, to do predictive maintenance using GCP. So bringing in all of that information is great and visualizing it is great, but we are taking that next step forward, bringing in contextual data sources and identifying those types of failure events that require intervention. So the big question is why AI? Why now? And the move from kind of descriptive analytics to predictive analytics is driven by a maturity in AI technology. So this won't be new to a lot of you in the room, but as businesses are evolving faster than ever, data has to keep up and deliver the insights for those individuals within the organizations and bring that data to the front lines to help them make the decisions as and when they're needed. And capitalizing on data is not new. People have been doing it throughout time. The difference now is that this evolution of compute and this evolution of scale and speed and diversity in the types of models that are available and the type of big data technologies that are available through Google Cloud, from a capture all the way through a storage, processing, and insights perspective, are pretty much ready at this point in time to help deliver those insights. It's not about big or small data. It doesn't matter how small the data set is. It's about how you leverage it with the insight from the industry for the right use cases to deliver value to those individuals as well. And this is all about the move from understanding or hindsight through to insight. So how do you get insight available within your organization to know where you need to work? And the overall overarching aim is getting to foresight, where you're able to go and do things before they occur. We've all seen Minority Report, right? And just to touch on this as we're talking through this, Hitachi has deep experience within the maintenance world. Hitachi has deep experience within the IoT world as well. So we are able to leverage not just the AI components of Google, we're also able to leverage the experience that Hitachi has across the maintenance space, from a descriptive analytics space to predictive, and also some of the newer things around prescriptive analytics as well. So for example, Hitachi has AI solution cores that we were able to containerize and bring into the Google environment to do certain things such as operations risk score, so driver behavior. And we've used some of that insight, not necessarily to detect those faults, but to support that data set that we're using for the brakes example, which I'll take you through later today. And also, there's really important things there around remaining useful life estimation and fault predictions around other use cases that we haven't necessarily touched on in this space. But the purpose of me showing this and explaining this is to say we have great experience in this space, and we're able to bring those with whatever use cases people are looking to work on as well. And all of this is in the pursuit of total operation, optimization, and automation. So it's about moving from the hindsight world to insight, and also to the optimization space where AI is not only helping you understand what you need to do, but orchestrating and running that for you as an end-to-end system. We're not quite there, but that's where everybody should be walking towards as well. So I'll stop there for 1 second, just do a quick time check with Andy. How are we doing?
Okay, fine, yeah.
Perfect.
Yeah, carry on.
I'll let you know that I get told that I like to talk a lot, so just have to use Andy to keep me honest.
Yeah. I'm here to throw him off the stage in a minute. Don't worry.
Perfect. So before we actually get in and start showing you a bit about the architecture, I'll describe some of the features of what we've been doing, and when we do the demo, I'll explain some of those pieces as well. So our fleet operations platform does the normal condition monitoring element, so you bring through the data, you show some of the basic elements like miles driven, where the assets are, and those elements. We also do advanced failure prediction, so we have 2 use cases we're talking about today. One around failure for air conditioning units on fleet vehicles, and one around failure prediction for the brake pad or brake elements of the vehicles as well. We also have anomaly detection models where we look at peak performance versus norm performance. We bring in the intelligent driver score elements that we talked about, and we surface all of this to our end user, being the maintenance planner, through prioritized maintenance dashboards where we offset the real-time predictive recommendations against some of the cyclical work that's been going on as well. And we also surface that information through mobile and glass applications to the engineers who are out there doing the inspections and completing that work. Perfect. I'll now hand over to Andy.
There you go, Abid.
Thank you very much. He'll give you an overview of some of the architecture components about what we've been working on.
Cool. Hi. So yeah, we've obviously talked about the fact that the end-to-end capability, we're looking to use GCP for this. We've built the platform with a number of the components. So again, maybe just give you a bit of an insight into the high-level platform. Predominantly, this is based around Google's blueprint for IoT. You probably see lots of diagrams in this area. This is very summarized. I think the important aspect in all of this is not, this architecture doesn't necessarily fit every use case. We have to bring in and use different components of the GCP family to address some of the challenges. So again, depending on the speed that you need to consume the data, whether you're looking at these things in real time, whether you want to do things in batch, you may end up using different products. This is just I guess, the common ones that you would tend to use in such a solution. From our point of view, I guess more recently, Cloud IoT Core is something that we've introduced. Some of our clients historically wouldn't have used this. They would have used direct connections or stored the information centrally, but now with IoT Core, we can connect directly to these devices. And again, as part of the platform, we've proven some of that technology out. So this is here to, I guess, predominantly this is not just for the sensor data. I think as Mubine's mentioned previously, there's lots of other information you want to bring into the platform to actually enhance the prediction models. And again, different clients have got different volumes of information. So I think back to one of the other slides, from a Rails perspective, if they have a lot more data potentially than what you maybe have on a car. So you've obviously, the platform is here, it can scale out, you're able to process it, you're able to use the power of the GCP based on the input, the data that's coming into the solution. I think, again, what we've touched on previously, there's lots of talk about containerization. And again, coming back to the algorithms that, or the solution cores, as Hitachi likes to call them, that we've got, we can obviously bring those into the platform. So again, we don't always have to use GCP products. We can introduce our own technologies and things that we've invested in previously and developed over a number of years. So we also can include those. And again, we'll see some statistics at the end where we've actually done that, and we can sort of show where sort of the benefit of using the platform. So, we've talked about the back end, as I say, lots of components. From a visualization perspective, we've utilized Data Studio to do what we would class the standard dashboard capability. So again, from a maintenance planner's perspective, that is where we are surfacing the consolidated information. So that's where the person is then making those decisions to support the future, I guess, the maintenance effort that's required. And again, Google AR and Glass, so that's where we're doing the guided investigation. And again, all the components interacting with the GCP platform, taking data in, giving data back after some of the investigations have happened. I guess these are some of the differentiators that we can call out from GCP. Obviously, from our perspective, end-to-end capability. So we can obviously collect the data, process it, analyze it, and then obviously do the recommendations off the back of it. That's obviously very important. I think as we mature within the area of predictive maintenance, having the ability, and I think probably some of the announcements that have come out from Google this week, they're continuously investing in this area of machine learning, as well as what Hitachi are doing. So we can bring our enhanced capabilities and use, obviously, Google's enhanced capabilities to progress that as we go through. Security is a big thing. I think Google is best in class from a security perspective. A lot of the time when you're configuring the platform, it's just there. It just does these things. You don't have to worry about it. There's lots of out-the-box capability that we get with the platform. And again, obviously, we've talked about different clients require different needs. Speed, performance, the scalability is obviously very important for when we're doing a lot of the work around the algorithms. Again, I think we've probably touched on this previously, but my background is BI, and it used to be very. You would go and gather some requirements from an end user. You'd write a document. You would then go away and build it. And I think in this day and age, you've got more parties involved with the whole process. Data engineering is very key. Data is no good if it's not meaningful, clean. So there's lots of interaction with data engineers and the data scientists. But obviously the important people on there is the business operations people, the subject matter experts who understand how these lovely objects work, and they need to provide that input and guidance. And again, I think we find that is very critical and key to making sure that anything you develop that gives you the right outcomes. So why Hitachi and Google? I think we've touched upon it previously. Hitachi's got a heritage within the industry space, and I think probably as a single tagline, it would probably be, we're using Google as a platform to bring out our, I guess, industrial expertise to the market. We've got we can see the power and the benefit of using GCP when we're developing out these solutions.
Perfect.
So, yeah, that's a very brief overview of the technology. I think, as I say, we're now going to just go through the actual the demonstration of the application.
Perfect. Thanks, Andy. Now, I'm assuming all of you have already come past the booth and seen the demo, so this will be the second time you've seen it. Yeah? I'm sure that's already happened. So, just to give you an overview of what we've done with our client. So, obviously, our client doesn't just have Lego vehicles. Lego isn't the enabler for AI to be a success and drive insight. It's just an enabler for us to demonstrate some of the pieces we need to. But essentially, our client is having a lot of work that needs to be done from a maintenance perspective around two specific use cases. So AC, so air conditioning, HVAC in the States, and also their brake elements. That's where they're spending a lot of their time in terms of maintaining their fleet of vehicles. And this fleet of vehicles is dispersed across a large geographic region, and within their organization, they have a number of mobile workforce users, but they also leverage a contractor pool of resources when they need to. So we started to think end-to-end about how we can provide a solution to help them both understand where to focus their attentions and when to create the right interventions before assets failed, but also how they could get the contractor resources the right information when they needed it visually as well, because the last thing you want as a worker is lots of paper. The key thing around all of this as well is from a data kind of management perspective, our client has access to the data that comes off the vehicle. So in Europe, there's an OBD2 terminal that sits inside a vehicle that streams back lots of information about that vehicle. Now, a lot of that is just noise, right? You get lots of information, but you need to figure out how that is useful for you. So I'll just quickly touch on one of the use cases we'll talk you through today around air conditioning. So our client was noticing they have a lot of issues in terms of client feedback for the vehicles that they're borrowing around AC performance issues compared to some of the other maintenance elements, and a lot of their maintenance work was around repairing or servicing these AC units across their vehicles, and each vehicle obviously slightly different unit, slightly different maintenance schedule or pattern that they have to follow. So we worked with our client to understand what data points would be useful to pull back from the vehicle around the AC usage. So looking at the time it took to get from start temperature to the desired temperature is a great starting point in terms of both cooling and heating. But then we looked at failure information we could gather from that client, so their maintenance records, also the external data sources that are required to support that AC use case. So how do we bring in external temperature information? How do we at least test the value of putting additional sensors within their fleet vehicles so that they can have a robust data set to be able to get to a fault prediction perspective. What our client also noticed and has from an SME experience perspective is an understanding that if you get to these air conditioning issues in time, you can actually remedy them before they turn into total failure. So for example, if an asset has degrading performance from an AC perspective, and our model is flagging that, and we know that that asset was serviced, let's say, within the last 6 months, it really shouldn't be having any performance issues. That is probably an asset we want to prioritize getting to work on, because Those issues within an AC unit are usually down to pressure eroding out of the system, coolant leak, those types of pieces. And they're able to identify, based on what we've created, those elements and those areas where you could get to it and repair the hose or improve whatever issue there is with it, so the whole unit doesn't fail. So we'll take you through that use case. We have two focuses from this perspective. So data dashboards, which Andy will talk you through shortly, where we're surfacing all that information, and we'll talk you through that. And we also have the guided AR inspection piece for that mobile workforce as well. Here you go, Andy.
Thank you. So just looking, I guess, from a dashboard perspective, this is very, we play across more the bread and butter BI type stuff, with the means to, you know, surface the information that we need to take action upon. So again, from a dashboard perspective, what we're doing here is we're effectively summarizing the events that have happened. Now, those events may be that the system itself is generated, or actually in this case is where we've executed the models and it's come up with these recommendations of the things that need to be actioned straight away. So again, this is more from a, I guess, from a maintenance planning perspective as opposed to the individual. Again, we can obviously drill into the detail of that. We can go and see the specifics of where this thing has failed. So in this case, air conditioning. And again, based on, so these condition scores, obviously things that this is a score that we generate. Again, that's based on the input factors for the different components and models that we're predicting against. So again, just a visual representation of the information that we're then ultimately going to go and do some inspection against. And that's our other beautiful car. We've sort of said that we've talked about HVAC and braking, but as part of the data set that we actually had, the data scientists were actually started to, I guess, evolve that, if you like, and started to look at things around drivers' behavior, because that's obviously a key aspect into potential degradation, especially things around brakes, where you have a driver who's continuously braking and driving, I guess, not to the optimum. Again, something that's very useful within the fleet, from fleet industry's perspective. It's also used on the trains. It's similar sorts of things where you want to try and optimize that. And again, we've built out some capability. And again, these dashboards here are just showing I guess, the aggregated views and some of the key metrics that people want to capture, where when you're starting to look at driver behavior. And again, we can drill into that detail. I'll quickly skip through these, but again, so it's an education thing. So it's all, we can obviously use that from where we have to go and actually inspect and service the vehicle, but we can also use these things from an education perspective, because obviously if the same driver is causing similar sorts of problems, then we can obviously, I guess, take corrective action, and which ultimately will obviously improve the vehicles he's driving or she's driving.
And just to build on that as well, so our clients now looking at the data we're bringing back from a brakes perspective and driver score perspective to say, well, that's good for maintenance, but how can we start to surface some of that information to that end user, that driver, to let them know that they're not driving optimally, they're accelerating harshly or braking harshly, not as a way of telling them off, but as a way of helping them understand their performance. We carry health monitoring applications, and it's just about seeing what you're doing, because you may be, let's say, naive to the fact that you're not driving efficiently.
Cool, thanks.
Sorry.
Okay.
Perfect. So this is the part where you actually see the Lego Porsche is not just here to look nice. So essentially, in this scenario, we've created an application for our client's mobile workforce. Our client wants that mobile workforce made up of contractors to be able to execute the right activities. From a maintenance perspective, there's 2 or 3 things we're doing here, and this is all about the inspection workflow. Within this, and I'll talk the examples through as we've got the video playing in the background, but essentially, within the maintenance world, you would be surprised, but there are a large number of times where somebody goes out to work on a vehicle or an asset, regardless of if it's a fleet asset or any other asset, and they work on the wrong vehicle. I come from a background in rail slightly where that was happening, everybody feels like they know where something is. You get the information from the database and it tells you it's in that location, it's a fixed asset, you've been there a million times, you get there, you see the checklist, you know what you need to do, you do it, you mark it as done, you don't realize there was actually an identical unit right next to it and you worked on the wrong one. So we use AR for visual identification through Google to help a user understand that asset. Now with vehicles, it's easy because we have license plates, we have registration plates for those vehicles. And with our client, they have 3 different types of vehicles, so we've trained it against those 3 vehicle types, but also the license plate as well to remove that chance of error. For the demo purposes you'll see today, we've retrained the model and we've dummied some of that data and sanitized it, so you can actually see the AR image recognition against the Lego unit itself. The other thing we do using the application is we help the user understand where to focus their attention for this inspection. So for example, I may be a, I don't know, AC inspection engineer, however, I may have not worked on all the cars that have ever existed in the world. So it's about surfacing the information for that vehicle, and it's all about us then training the models to recognize our clients' vehicles and their assets. So scalable outside of just vehicles and fleet assets, but immensely powerful to helping people understand what they need to do. So in this scenario, we're essentially, the piece I talked about, the model has highlighted an AC efficiency issue. This could be due to gas regulation within the system or a leak somewhere. The AC unit was serviced quite recently, so it's actually something that we're looking for our client to target and get them out to complete that inspection. And we will go ahead and we'll complete an inspection against that unit. So this is where we're hoping the magic works and the video will play. I will probably pause it from time to time just to recap on some of the things that we're doing. This is the same overview of the use case and scenario that we're working on, but essentially, user is able to see the job queue, the work that they need to go and do, and obviously they get a lot of information through from our model, so whatever we hold in the model will surface the right information to them about what they need to do, where the asset is, and then we'll keep it playing. We essentially help them navigate to get to wherever they need to do the work on, so for example using Google Maps to get them to their location. For simple purposes, we've simulated that for this part. They get to the asset and they need to identify the asset. So the piece I talked around earlier around working on the wrong asset is extremely powerful. We need to make sure that we fix things right first time on the right asset. So if we click play, this is where you'll see the AR element come in, so the recognition element. The user hovers the mobile or glass device across the asset and data is pulled back from our database to show the pertinent bits of information that we want to surface for that use case and for that user. For this demo purposes, we've pulled back the mileage, we've pulled back the asset condition score, and the focus area as well. Now, as we click play, the app also provides information, for that user, so that user understands what it is they need to do. So from an AC inspection perspective, there's usually 3 things you'll go look at: the condenser, the pressure that's within the system, but also check the fixtures and fittings around the hose. Is there any leakage happening in that space? So essentially the user's given basic information and then they're guided through this. So if we click play, start inspection, they'll be told obviously where they need to focus their attention. They'll scan that asset, so this is using the camera to pull back visual information, check against our model, and then it pulls back the information around what it is they need to do. So at this point, we've called out the 3 inspection areas. Now, for different vehicles, different cars, you'll have different areas to have the hose or have the condenser unit, and this allows them to click in and see what it is they need to work on and the steps they need to carry out as well. So it's removing the end-of-job checklist activities, and it's focusing that user on what they need to be doing, when they need to be doing it. This can get as complex as you want it to be, dependent on, if we pause it just there, Andy. Complex as you want it to be, depending on what asset you're working on. So it's really powerful. And then obviously the information, you can press play, sorry, is pulled through, and that passes through to the database so that we can have positive feedback around what was completed, whether there was actually a fault, and it's reinforcement with reason codes so our model can learn as we go. So that's the demo from the AR perspective. And this is where we're hoping that it works and we can go next. again, the value of why we're doing this. So the value of why we're doing this for our client is to help them reduce the maintenance burden and improve efficiency from a maintenance perspective. So go and maintain those assets before they fail, so you don't have to spend more time and effort when those assets are out of commission later on down the line. Improve the uptime for those assets. So if we can get to a vehicle and do a small repair as opposed to having to do a large replacement, it's then available to be used by other parties, and reducing that capital cost. So you do not want to be going out and repairing AC units as frequently as you currently do. You want to be able to maintain those units to a higher level of efficiency so that they last a lot longer as well. Perfect. So key takeaways, and I know you're all probably wondering the so what and how much all of this would factor in from a data processing perspective. I'll pass over to Andy there.
So this is just, I guess, an example of, why the platform is really useful. As part of one of the air conditioning investigations, we did some analysis, and we tried to extend the data set that we had to simulate over, I think, 12 months worth of information. So you can see there with those big numbers, you know, if we were to try and do this, I guess, on premise, we'd probably struggle. So this was a job that we executed that obviously spun up, as you can see, quite a large volume of compute. Took about 22 minutes to run, and it only cost $12. So, you know, when we give this sort of ability to our data science team, they're very happy because historically they're very, I guess, mindful of spending lots of money because they know how much compute power costs. But when they were actually amazed when they saw the results of actually how much these things cost.
Perfect. And in terms of the key takeaways from a, let's say, learning experience with our client, so fleet optimization is a continual effort. So it's about understanding what you want to do, where you want to do it, and what you want to try and improve from a use case perspective. So AC and brakes was the start, and our clients now learning all the other things that they might want to do based on the data we've been able to pull up and surface for them. Data isn't enough. So the key point is, as much data as you can bring back isn't enough. You need to combine that data with contextual information, but also with that subject matter expertise and the ability to add new sensors and bring in additional data points that you didn't originally capture because it can benefit what you're trying to prove. So for example, with the use case around brakes, we brought in the additional data around driver behavior because it's very likely someone's driving badly, brakes are going to be impacted. It's not the sole factor for why that score is calculated, but it's a combination factor. Then we bring in things like terrain, weather. Do those have an effect on how people are using the vehicle from a brakes perspective? And the other key takeaway from this is the speed and scale that you can move at from Google's perspective. So you have all of the access from edge data capture to authentication of new devices using IoT Core, to the use of ML and containers to do the analysis against that data set, but also robust and powerful visualization tools to help provide the information for that end user to help them complete their job. So for example, when we were talking about the guided AR investigation application, we tried it in two ways. We tried it initially with just a mobile application for a user, and then we tried it with the AR piece. And side by side, the client noticed also that the people who were using the AR application were paying more attention to the work they were doing. Now, maybe that's because it's new, novel technology, but maybe it's that little nudge that you need to anchor you in the work that you're doing. It's so easy to say, well, I've done this form a million times, I know what I'm doing. If you're having to use the camera and those elements, it focuses your mind on the asset that you're working on as well. The other part here is all about technology is important, but it's technology plus the business context that helps you deliver success and deliver insight. Your people are your strongest asset. This whole process is all dependent on using AI, advanced analytics, through a change journey with your client, understanding what value you're looking to unlock, understanding the focus areas that you're looking to prove value in, and demonstrating that value to bring other people into the fold and keeping those individuals involved throughout that process, either through visualization tools, so soft prototypes that you can work with them to help the business understand what is coming and adjust what is going to be delivered in an agile way so that what they end up receiving is actually beneficial to what they're doing. Perfect. I think we've elapsed towards our time, and I think we have about 5 minutes left for questions. If any of you are interested in understanding a bit more about this, by all means, do take a picture and scan that QR code, or also have a look on the Hitachi Google website. You'll be able to access our information from the applications that you saw as well. And thank you very much for coming along today.
Thank you.